Okay, so a lot of y'all, okay, your grade hopefully went up with the last test. It was curved a little bit, but I'm not going to print out another progress report because it's like a gazillion trees. So, print it off, parent signs it, turn it in. I'll give you 100. Hopefully it'll bring your grade up. If your grade is bad, your parents are going to see it eventually. So at least get some extra credit off of it, okay? Then your thing from yesterday, okay, that we did in class. Remember, you're going to get 3 exam reviews. Yesterday was day 1. Okay, all 3 of them add up to a test grade. That should be an easy 100. We're doing almost all of it together. Okay, so if you have like a 60, you can easily pull that up to a 70. Now below a 60, you might have to turn in some stuff. When's the last day for late work? Friday.
If I like have missing homework, I just give you homework, right?
Sure. Alright, you ready? So, number 1, you have a little graph. Now, I don't know what happened with this line, just ignore it. This is the x-axis, okay? Where's f of negative 3? Okay, well, f of negative 3 refers to a y value. So I count to negative 3. Here's my graph. What does it equal?
1.
Negative 2. Now, this line, remember, we're ignoring. I don't know why that's there. So if I'm tracing my graph at negative 3, I'd be here. Yeah? Okay, next, I want f to equal negative 3. Well, if f needs to be equal to negative 3, that's the y value that they want. So when does my graph hit a low point of negative 3? Okay, at 1 and 5. Yeah? Okay, so I'll put here, this is a y value, versus if they put it in parentheses, then it's an x value. Okay? Should know the difference between those two. Okay, so now that we've reviewed it, what's f of 0? Well, then is that an x or y? Next, it's in parentheses. At 0, where's my graph? Open circle. Undefined. Remember, open circles don't count.
Wait, so for b, it's a y value, how do you put x?
Okay, so look guys, every time you're going to have this. So, they're either going to give you the number on the inside and you're going to give them the y value. Or they're going to give you the y value and you're going to give the x value. Does that make sense? So here, they're telling me y is negative 3. What x does that happen at? Versus here, they're saying x is negative 3. What y goes with that? So if they give you x, you're giving them y. If they give you y, you're giving them the x that goes with it. Okay? Now, zeros, you should know that word. That's the same as an x-intercept. Where do I have x-intercepts on this graph? Remember, this is the x-axis. 6 and negative 5. Okay, because that's where my graph hits 0. Where is f of x greater than or equal to 0? Greater than or equal to 0 means I want above the x-axis. Where am I above the x-axis? Remember, this is the x-axis.
Negative 5 to negative...
That's negative 7, right? Because if that's 6, then that's 8.
Yeah, except.
So that'd be from negative 7 until when? Negative 5, and then from 6 till infinity. And you see the arrow on there? That's why we're going to infinity. So it'd be from negative 7 to negative 5. That's where I'm above here. And then from 6 till infinity. Remember, you can use the little u to show that it's more than one group.
Do we have to do a bracket?
Good question. Technically, it should be a bracket because, do you see the equal to? Okay, that means it could be greater than or touching 0. So thank you for correcting that. Now, which one can I not turn into a bracket? The infinity. Okay, remember, infinity is always open because you can never really touch infinity. Okay, next one. F increasing, F decreasing. Okay, F will be increasing when the slope is positive. So look at your graph. When do I have a positive slope? There's just one interval.
6 to infinity.
I just want to have a positive slope. It happens before 6. When does it start? 3. And then this whole part, what's my slope? Uphill. Yeah? So I would say from 3 till infinity. And then I'm just going to put positive uphill slope. Okay, when is f decreasing? What am I looking for? Instead of a positive slope, what do I want? Negative slope. Where do I have a negative slope? -7 till when? -4. And then what happens when it's flat? Does that count as decreasing? No, that's flat. And then it's decreasing again. Here. So I would say from -7 to -4. Union. And then I'd say from 0 until 3. Now make sure it would be from 0 to 3, okay, because that's where it starts going downhill again, okay? Also, one thing to be careful about is, why am I putting 0 instead of -2 here? Because 0 is the x value. That's how you list intervals. Doesn't matter that it's at -2. It starts at, that'd be 0. Okay, then it says, as x goes to infinity, what does f of x go to? Okay, very good. Do you remember what x to infinity means? You're looking at the right end of the graph. So if I'm looking at that end of the graph, which way is it pointed? Up, so that would be infinity. Okay, then it says as x goes to 0, what's f going to? Okay, well 0's here. As I trace my graph from the left side and from the right side, what is my f of x getting closer to on either side? -2. Now, is there a point there? No. But it doesn't matter. You're just looking at what it's getting closer and closer and closer to. Okay, so as I approach 0 from the left, my y value is staying at -2. As I approach it from the right side, it's getting closer to -2. Okay? Alright, next little section. Let's do some inverses. Okay, number 2. How do you find an inverse? Do you remember? Okay, switch the x and y. And then solve for the new y. So, look at your equation. Instead of being an x minus 1, what's it going to be now? Y minus 1 cubed plus 5. And then instead of being f of x equals, which is really a y, I switch that to an equals x. Okay, from here, what do I do first? Subtract the 5 across. So I have an x minus 5 on this right side. I have a y minus 1 cubed on the left side. How do I get rid of a cubed? Cube root. Cube root. Do I have to put a plus or minus on a cubic root? No. Trick question. Now, what if it was a square root? Would you have to put a plus minus? Yes. Okay, from there, what do I do with the minus 1? Do I add it to the 5?
No, on the outside.
No, on the outside. Good. So it'd be a plus 1 over here. Okay, let's do number 3. Okay, what do I do first? Take the x and y, flip-flop them. So instead of an x minus 7 up top, now it's a 3 to the y minus 7 plus 10 equals 0. Or, oops, equals x. What do I do first? Minus the 10. So I have an x minus 10. Good. Now, what type of log do I want to use if it's a 3? Log 3. What if it was an e? What kind of log would you use? ln. What if it was a 10? What would you use? Log 10. So whatever that number is, you have to match that base. So I'm going to log 3 both sides. Log 3 and 3 cross out. Y minus 7 comes down. And then from there I have log 3 of x minus 10. What's my last step? Add the 7, add the 7. And then remember, you can't add it to the inside, you have to keep it at the back. Now, keep in mind that your semester exam is multiple choice. So, if you didn't want to do this, let's look for the pattern. We already talked about this like 2 months ago, but we'll review it. If it's a minus 1 on the inside, what does the inverse have?
+1.
Plus 1 on the outside. If there's a plus 5 on the outside, what is there? Minus 5 on the inside. If it was a cube, what does it turn into? Cubic root. Okay, look at this one. I have a plus 10 at the back. Now I have a minus 10 in the middle. Minus 7 on the inside, plus 7 at the back. Started with an exponential 3, end with a log 3. Remember, exponential and log are partners. What is x squared's partner? Square root, right? Squared and square root are partners. Okay, and then cube and cube root are partners. And then exponential and log are partners. So, run through your list. You're going to circle inverses. They're exactly the same or neither one.
That's an inverse. I mean, yeah, that's an inverse for A.
Letter A.
Then you can neither.
It's a neither. What's wrong?
There's +2.
What?
Plus 2 should have turned into a
Oh,
what?
minus.
Not going to work. That's a neither. Got 'em. Okay, next one. Look at it. Hello? Mm-hmm.
Self-serve.
Okay, I'll send her. Thank you. You look like you know it's for you, Ariel.
Yeah.
Next one. Inverses or no?
I think it's an inverse.
Neither. Because why?
That minus.
Cubic root and a squared. Are they partners? Got 'em. Okay, next one. Plus 10 turn to a minus 2. Minus 2 turn to a plus 2. Square and a square root. Inverses? Yes or no?
Yes.
Yes. Okay, next one. Exponential 2 to the 5x. Exponential 32 to the x. Are exponentials inverses with other exponentials? No, but they could be exactly the same if you use a common base. What is 2 to the 5 the same as? 32. So they're not inverses, they're equal. Equivalent means equal. Okay, so I'm going to put on here, though, just to make sure there's one like this on your exam. Okay, 32 is the same as 2 to the 5. And then you would leave the x left over. Okay, that's a common base. Example. Okay, then last one. 4 and a fourth. Okay. Well, 4 and a fourth aren't equal. Can they be inverses? Think about how do you find an inverse? You switch x and y, right? Do I have an x to switch with anything over here? No. Do I have an x to switch with anything over here? No, that's a neither. Okay, you cannot have an inverse. This is the same as like y equals 4. And so if all I have is y equals 4, well then I can't inverse that. It doesn't even have an x for me to switch with the y. Does that make sense? Alright, turn the page. Next ones, I don't want to do all these. We'll do B and D. Letter B, you're just listing the transformations. Which way would letter B be shifted?
Compression.
Okay, it is going to have a compression. Okay, so we'll put this 1/3. Okay, it's going to be reflected down. And it's going to have a vertical compression. Okay, now let's talk about the shifting second. Good job. Now, actually, do y'all remember the cutoff from a compression to a stretch? Where does it switch from one to the other? 1. Smaller than 1, compression. Bigger than 1, stretch. Okay, next let's talk about shifting. I have a -7 with x. Which way are we moving it? Okay, to the right 7. And then up 6. Okay, and remember, the x is always going to be opposite from what you want. Okay, let's do letter D. First thing I noticed, I got a little 10 there on the outside. What's that? A stretch or a compression? Okay, so I have a vertical stretch. Okay, and that would be by a factor of 10. And I didn't write that last time, but if you want to put it up here, what would our factor be for the vertical compression up here? factor of a third. Okay, now we're going to ignore the 2 for a second, because I don't know if y'all are going to remember that one. We'll see. Okay, x minus 6, which way are we shifting? Right 6 and up 7. Very good. Okay, when the stretch or shrink is on the inside, does it still stretch if it's a 2? You remember? When it goes inside, it turns into the opposite. So if it's a 2, that's really a compression. So this 2 on the inside means horizontal compression of a half. So remember, if it's on the outside, bigger than 1's a stretch, smaller than 1's a compression. But when it's on the inside, it does the opposite. Now, the other word I want to point out to you that we didn't really stress a ton is on the outside, it's a vertical. On the inside, it's with X, so it's called a horizontal stretch or shrink. Okay, so why don't you do letter C? Got a 1/3 on the inside, horizontal or vertical? Okay, that'll be horizontal. Will it be a stretch or compression? Stretch, because it's on the inside, and that switches up, just like with X, it's going to be backwards. Now, when it was a 2, it was a factor of a half. What's it going to be if it's a third? Factor of 3. Okay? Then my shifting, I got a -2 and a +10. Which way are we going? Right 2 and up 10. Good job. Okay, 6 and 7, you should know how to graph these, but if you don't, you have a graphing calculator, right? So we're going to skip, do you want to do one of them? 6 or 7? 7? Okay, let's do 7. Which way are we shifting? What's my transformation?
Right 6 down.
Right 6, down 4. Very good. Okay, this number tells me to the right 6. This number tells me down 4. So that'd be here. Okay, then remember that your 2 to the x graph, you could easily type that into a calculator. It has a flat asymptote at y equals -4. Okay, remember that is an exponential graph. Now remember, I can't touch this line, so I can't start my graph right there. Where do I start it? Do you remember? 1 above. Very good. So I'm going to put my little dot right here. And then remember that my graph's going to go up on the right and down towards the asymptote on the left. What is the domain of the graph you just drew? All real numbers. What's the range? Okay, very good. So my domain is all real numbers because I have arrows pointing both directions. But my range, my lowest point, comma, my highest point, would be from -4 till infinity. Why am I using a parentheses on -4 instead of a bracket? Because can it touch -4? No, that's why. Okay, next one, it says, as x approaches 6, what is f of x getting closer to? Okay, well, look at your graph. Here's 6. As I trace from this side, what am I getting closer to? What y value? What y value? At 6, what's my y value here at that dot? -3. Okay, remember, -4 is the line I can't touch. So as I trace my graph from this side, it's going to -3. As I trace it from that side, it's going to -3. Okay, then what about as x goes to -infinity? Is that the left end or the right end? Negative is the left end. What is my graph getting closer to on the left side? -4. Now, does it ever get there? No, but x is approaching -infinity. Y is approaching -4. Do y'all want to do this one? Or y'all got it?
No.
No? Okay. Alright, turn the page. One more little page left. That's it. Okay, y'all remember how to expand logs? Okay, how do I separate a log that's divided? Subtraction. So I'll split that up. I have 5 divided by 3x squared. So that'll be log 5 minus log 3x squared. But these guys never want to share. They cannot be together. So when 3 and x separate, if they were multiplied, how do they separate? Good. So it'll be log 5 minus log 3 plus log x. Now, I made a mistake. What's the mistake?
The 2 0.
Okay, the 2, yes, but another mistake. Parentheses. Where do I need parentheses around?
The 5.
3 and x we're sharing,
Yeah.
right? So when I split them up, I have to make sure they're still sharing that minus sign. Because it wasn't just the 3 that was on the bottom, it was both of them. And then I'm going to move my 2 down like Bree said. So I'll have log 5 minus log 3 to log x. Make sense? Okay, look at the one right next to it. What do I do first?
You're adding.
Okay, I am going to separate with adding, but I got this 3 on the outside.
Put it in the front.
Put it in the front. Good job. So I'll have 3 log 2 x squared root y. So the first thing I do is I move that 3 out of the way. Okay, then from there, these guys don't want to share. Are they multiplied or divided? They're multiplied, and when I separate multiplication, I do it with a plus. So I'm going to have 3 log 2 of x squared plus log 2 root y. What mistake did I make? Parentheses. These guys were sharing the 3. They got to still be sharing the 3. Okay, then my last step is to move exponents down. What exponent do I use for a square root? That's really a 1/2. And then I'll drop it down. Drop it down. So I'll have 3 parentheses 2 log 2 of x plus 1/2 log 2 of y. Okay, so when you're looking at your semester exam, you know what to look for. Look for parentheses that are missing. Look for square roots turning into 1/2. What if it's a third? That would be a what type of root? Cube root. Okay. Alright, next one. We're putting our logs back together. Take a look at part A. What do I do with the 2 first? Now I'm trying to get it back to 1 log instead of separating. Bloop. Now that's a what? X squared. So my 2 is going to move up. So I have a 1/2 log x squared plus log x plus 10. So far so good? Okay, these logs are added. How do I combine? Multiply, very good. What is x squared multiplied by x plus 10? Well, I'm going to have to distribute. X cubed plus? Good job. And then what's my last step with that 1/2 in the front? Bring it up. And when a 1/2 moves up to be an exponent, what does it turn into? Square root. Okay? So step 1, I move the squared up, the little 2. Step 2, I multiply to combine to a single log. And then step 3, I'm going to bring that 1/2 up, which is going to turn into a square root. So your final answer would be this. Log of x cubed plus 10x squared inside a square root. Okay. Alright, last one, letter B. First thing I want you to do is move all your powers up. 3, 1/2, and 1/3. So I'm going to have log x minus 2 to the 3, log x plus 10 to the 1/2, log y plus 5 to the 3rd. Now notice, when I pull my third up, I'm not pulling the negative. Leave the negative. We know what we're going to do with that later, right? Okay, step 2, I got to change my half and my third. What do I change them to?
2.
What do you mean 2?
What were you asking?
What do I change my half to here?
Oh, square root.
Square root. And what do I change my third to? Cube root. Okay, then from there, my first 2 logs are added. Addition means I do what with their arguments? So I'd have x minus 2 cubed multiplied by x plus 10. Now, question. Can I, like, distribute or anything like that here? Not if that's in a square root. If it's in a square root, it can't go with anybody else. It just kind of keeps to itself. Think about it like it's in jail, okay? Now, this one was minus. Where's that one going to end up?
The bottom.
These 2 get multiplied, but that one gets divided. Okay? So you'd have a cubic root crap on the bottom. And then y plus 5. Make sense? And that'd be your answer. Thank you.
6 period logs.
Okay, perfect. Thanks. All right, last little section. Okay, next one, number 10. You're just doing log loops. Okay, where do I start if it's an ln? What base is there, even though they don't put it? Okay, if it's a log, the base is 10. What if it's an ln? That's a base e. So remember, an ln automatically has a base e. If it were a log with no base, it'd be a log base 10. Okay, so I do my loop. E to the x equals e to the whatever that fraction is. E to the x equals e to the negative 2/3. Then remember, anytime you have a common base, what do you do? Cross it out. So x equals what? Boom. Good job. Next one, letter B. Do your loop. Oops. Take the second equals x off. Okay, do your loop. Where do I start? 16 to the 1/2 equals x. So I do my little loop, and then what is a 1/2 the same as? Square root. So that's really a square root of 16. What's the square root of 16? Thank you for the plus or minus. You're right. Now, logs, you can never have x be negative. So on your semester exam, if this were to happen, they wouldn't show the plus or minus. That's not wrong, but it's because logs, you can't have negatives in the middle. Okay? Last one, letter C. Do your loop. Where do I start? 7 to the x equals root 7. Now, those kind of have the same base, but not really, because 7's inside a square root. What can I turn the square root into? 1/2. And then they both have a base 7. Cross it out. X equals 1/2. Good job. 2 more left. Okay, letter A, do your loop. Where do you start? 2 to the x equals, bring it back around, 1. What exponent do I use if I need a 1? Do you remember? 0. Good job. And if 2 to the x equals 2 to the 0, cross out your 2's, what does x have to be? 0. Okay, last one. Do your loop. Where am I going to start? 2 to the negative 3. Back around equals random fraction x minus 5 over 2x plus 3. Now, we got to convert this into a number. What is 2 cubed the same as? Ignore the negative. 2 cubed is 8. Then what do I do if it's negative? Fraction. So what would I make it? Instead of 8, it'd be
1 over 8.
1 over 8. Good job. So I'd have 1 over 8 equals, and then cross multiply. Good job. Okay, and then I'll put here fraction because negative exponent. Okay? So because 2 to the negative 3 had a negative exponent, it becomes an 8th, and then I cross multiply. Let's do the 8 side first. If you already started, it doesn't actually really matter. So I'm going to do 8 times x minus 5. So 8 times x minus 5, you're going to need to distribute there. And then other side will be 1 times 2x plus 3. Okay. So 8x minus 40 is right. Okay, because I have to times that little 8 in. So it'd be 8x here minus 40. Other side, what do I get? 8x minus 40. Okay, 2x plus 3. Baby to the mama minus the 2x across. That's a 6x minus 40 equals 3. Add the 40. What's 40 plus 3? Then 6x is 43. Last step, divide by 6. Yeah, and you can leave it as a fraction or you can turn it into it if you want. Doesn't matter. Got it? Okay, so that clock doesn't work. You have what, 10 minutes? Okay, so if I don't already have your part 1, okay, from yesterday, turn that in today. If you were gone yesterday, the video's on the YouTube, message me if you need it. Okay, then this is due tomorrow. Then we have one more day tomorrow, and then on Friday you have a catch-up day. If you don't give me your review, though, I can't grade it and give it back to you for you to study. Okay, so if you wait till the last freaking minute on Friday, you're not going to get it back till Monday. And so if you care about studying and that's your thing, then be aware you got to turn it in before that, okay? Did you loop it? No, you're looping. Equals x. Just do a loop on it. No. When you loop, the log goes away. So it'd be 2 to the 6 equals. Like look at this example right here. We did 16 to the 1/2 equals x. When you loop, the log goes away, and then from there, 1/2 turned into a square root. Square root of 16 plus 4.
Okay.
Now for you, yours is going to be 2 to the whatever it was. So you'll have to look at your chart.
And then this. So I would loop the 9.
Yep. 9 to the 3x plus 9 to the x plus 2 back around equals 27. And then you'll use your common base chart to convert 27 and 9 to the same place. And now notice that you can't convert 27 to a 9 because it's not a 9. You'll both have to be degrees. And then one more thing here, make sure we just talk about this in your review. But remember that this is always the opposite. So if you circled C with a -6, which way would that have shifted your graph? Positive. And look at your graph. Is it shifted positive? Yes.
The review and like the.
Perfect. Thank you. And then I'll take your progress